Alrighty, so my last video was super long because we were working with similar figures. This video is going to be the complete opposite. It's going to be very short, very much to the point. We only have 3 full slides, 2 that I do and then 1 that you work through. So if we survive through this, it won't take long at all. Alrighty, indirect measurement is one of my favorite topics. I really enjoy it. I think it's a lot of fun. And the best part is even Kara has to admit that it has some real world applications sometimes. Okay, so when we work through an example, here's one. Okay, in the below picture, how far across is the river? Now, if we see in the picture below here, we know that this is a right angle, and we know that this is a right angle, just from looking at the picture. Therefore, if we would think about it, this thing would have to be flipped over and flipped back in order for them to be equal. So this side here has to match up with this side there, and across the river has to match up with that side there. Now, we want to know what the value of x is here, because obviously if you're in a river, you're not going to go measure that yourself. You have to figure that out on your own. So by using similar figures, we can actually solve this problem. So here, since I know that the 18 and the 42 have to match up, I can write 42 divided by 18, or I could write 18 divided by 42. As long as you're consistent, it doesn't matter. And then because the 42 came from this triangle over here, I then write x over the 16 on the other. And now from here, I just have to cross multiply. Okay, so I can simply go the 18 times the value of x, okay, through there, and then the 42 times the 16, which is 672. All right, so from here, because these are multiplied together, I have to divide by 18. And so I get my value of x is equal to about 37. And depending on what we labeled that, it could be feet, it could be inches. Well, from here it looks like it's obviously feet, maybe even meters. Okay, and that seems like a realistic distance, which I think is the best way to check. 37 feet seems like a realistic distance to getting across a river. So there's problem 1, nothing too terrible. Then we move on to another picture. Okay, we have trees. Okay, one tree is 40 feet up, and we know that for maybe it's the same height as our house, something like that. And we can measure the shadow as 10 feet long. Well, there's a different tree also in our yard that is 25 feet with a shadow, and we can't measure it. It's too tall. So we can use similar figures to figure out how tall this tree is. So the height here is going to be our value of x. We don't know that. So I'm going to write here the shadow of the small tree is 10, and I'm going to put that over the shadow of the larger tree, which is 25. And so then over here, I'm going to write the height of the small tree, which is 40. I'm going to put that over the height of the big tree, which is x. Okay, important to remember that when you're making the pictures, if you go small, or the proportion small to large, you would have to continue on and go small to large again. So now here we solve. Cross multiply. 10 times x is going to be equal to 25 times 40, which that's the same as 40 quarters, which would be $10, so 10,000? Yep, 10,000. So then from here, I divide by 10. So therefore my x is equal to, well, I can mark a 0 off, 100 feet. And if I think back to my problem, that seems like a very realistic height for that tree. And that's it. That's the whole problem. Okay? And last one. We have a picture here. We have a human being that is standing 6 feet tall with a shadow of 9 feet. And then here, this is going to be a square with a giant flagpole in the middle. And that flagpole's length, or shadow length, is 45 feet. And we want to see the height of the flagpole x. So see if you can pause this one and try to solve it and see what you get. Okay, so we're back. So I went, the shadow of the person is 9 feet, and the shadow of the flagpole is 45. And I'm going to set that equal to the height of the person is 6 over the height of the flagpole, which is x. And now I'm just cross multiplying. 9 times x is equal to 45 times 6, which is going to be 270. Then I divide by 9. And I end up getting x is equal to 30 feet. And that makes sense because the shadow is longer than the person here. Looks like the shadow is longer than the flagpole here, so the flagpole needs to be shorter than its shadow. And so there you go, that's it. All right? So now we go to our problems. You have page 258, 1 through 11. Okay, so there's 11 problems there. You need to get 9 right to move on. And then there is a worksheet. Okay, whoops, that was a mistake. If you don't get done, you'll need to get the worksheet from me. Alrighty, I promise you it's going to be short. There you go.